Hello everyone, let's discuss the problem LIS and LDS from Codechef Status 216. The problem statement is very simple. We'll be given a frequency array f of size n, and from all the arrays which can be built using f, we have to find the maximum possible score. Okay, and what is score? Let's say the score of an array A which is built using f is defined as minimum of LIS of A and LDS of A. Okay, here it is very important to note that LIS of A denotes longest strictly increasing subsequence. Similarly, LDS denotes longest decreasing subsequence, and it should be strictly in increasing or decreasing order. Okay, so the repetition of elements does not matter here. We only care about unique elements. Okay, so let's try to understand this problem by taking an example. Let's consider the first test case given to us. Okay, so the array f which was given to us, the frequency array f which was given to us was 211. Okay, which means that we can use the element 1 twice, we can use the element 2 only once, and we can use element 3 only once. Okay, using this frequency array we have to find out the maximum score we can get. Okay, so let's try to look at a few different scenarios. Okay, we want to maximize LIS and LDS, both of them, right? That is because score is defined as minimum of LIS and LDS, and if we want the best answer, if we want the highest answer, we always have to look to increase the values of LIS and LDS together, right? So using this frequency array, let's try to maximize the values of LIS and LDS first. Okay, so we can use the element 1 twice, which means that 1 can contribute to LIS one time, and it can also contribute to LDS one time. Okay, let's move to the next element. The element 2 can only be used once. Okay, so can one element contribute to both LIS and LDS? Will it be able to contribute to both at once? Let's understand that later. Okay, for now, since we only have 1, 2, let's add it to LIS. Okay, now comes the most interesting part. Okay, so the array which we built so far looks something like this: 1, 2, 1. Okay, so here we are building, in this part we are trying to build the longest increasing subsequence, and in this part we are trying to build the longest decreasing subsequence. Okay, so what about the element 3? We can only use it once, but will it be able to contribute to both LIS and LDS? My answer is yes. Okay, so the array which you will be getting, so the arrangement of elements which we'll be getting is 1, 2, 3, which is an increasing subsequence. Now let's start building the decreasing subsequence. So we can reuse one more time. So I'll place it here, right? So if you can see, if you will observe this properly, you'll be able to understand that 3 is also contributing to the increasing subsequence, and 3 is also contributing to the decreasing subsequence, right? So from this we can come to an observation that let's say in C1 we store all the elements with frequency exactly 1. Okay, and in C2, let's say we store the frequency of elements which is greater than or equal to 2. Okay, if the frequency is greater than or equal to 2, we can directly see that that particular element will be able to contribute to both LIS and LDS. So if we add 1 in LIS and if we add 1 in LDS, what will happen? The score we will be getting will increase by 1. Do you agree with me? Yes, that is because we are increasing the lengths of SIS and SDS simultaneously, right? So one such element will contribute +1 to the answer. So C2 such elements will contribute C2 times, right? So the answer we'll be getting using this count will be C2. Okay, so the score we'll be getting by all the elements whose frequency is greater than or equal to 2 is C2. Okay, what about C1? What about the elements with count exactly 1? Will we be able to use them in both LIS and LDS? Yes, we took an example where 3 will be able to use in both LIS and LDS. But what about 2? 2 is also repeating only once, right? But it is not a part of LDS. It is not a part of decreasing subsequence. 2 is only a part of increasing subsequence. Okay. From this, we are able to understand that out of all the elements which are repeating only once, exactly one of them will contribute to both of increasing subsequence and decreasing subsequences, right? So C2 plus 1, we can directly add it to our answer, right? And where is this plus 1 coming from? We'll be using one element which is repeating exactly 1, and it will contribute to both longest increasing subsequence and decreasing subsequences. Okay, what about the elements which are left out? Okay, we used one element from here, so the elements which are left out is C1 minus 1. What about these elements? So we can use them in only one of LIS and LDS, right? They cannot contribute to both at once. So it is better that we balance them equally. So if we have two elements which are left out, we'll add one to increasing subsequence, we'll add one to decreasing subsequence. Okay, this will increase our score by 1. If we have 4 such elements, we'll add 2 to increasing subsequence, we'll add 2 to longest decreasing subsequence. Okay, if we have 5, if we add 3 to increasing and 2 to decreasing, our answer will always be the minimum of these counts, right? So the score which we'll end up getting from this is 2. So from this we are able to understand that the contribution of the left out elements would be C1 minus 1 by 2. Okay, so putting everything together, our answer will be C2 plus 1. This is the contribution of elements which are repeating more than 2 times, and one element from the numbers which are repeating exactly 1 times, right? Plus C1 minus 1 by 2, right? So this is the elements which are repeating only once, and we are trying to balance them in both by adding them equally in LIS and LDS. Okay, so I hope this makes sense. But before we code this, we have to make sure that before adding plus 1 here, we have to check if do we have elements which are repeating once at all. Okay, if we do not have any elements which are repeating once, we cannot add them directly here, right? And before subtracting 1 here, we have to check if the count of elements, the count of C1, if it is greater than 1, then only we'll be able to use this formula, right? So the direct formula you could use is C2 plus minimum of 1 comma C1. This means that if the value of C1 is 0, do not use that in our answer, and plus maximum of 0 comma C1 minus 1 by 2. Okay, so this means that if C1 minus 1 by 2 is negative, if we have no numbers left, we'll be picking 0, right? So this formula will directly work, and using this approach, you'll be able to solve this problem in big O of n time, right? Thank you.